David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, simplifying radicals and surds. And this is the new chapter we're starting. And radicals are expressions that have root signs, which are these little square root signs. So we have two kinds of things you're going to bump into while dealing with radicals. Rational, which are things like the square root of 9, which just gets us 3. It's nice and clean. Square root of 36 is 6, and so on. You should know all of those. And remember, the square root of a perfect square is just the number squared. Okay, the other kind are irrational. So, like root 2. The 2 is not a perfect square. You can put this in your calculator and you'll get something like 1.414 and just ... It goes on forever without repeating. So this is called a surd. And almost always you want to leave it as root 2. Don't put it in your calculator and write out a huge long string of decimals. In this unit we want to leave our surds as root 2 or root 6 or whatever it happens to be. Okay, so I have 3 rules for you today for dealing with radicals. 1, 2, 3. The first rule, if I have root something times root that same something, something times itself is something squared, so that's root a squared. Now if you remember from our last unit, this is just going the backwards way from that. So the square root of a squared is just going to give you a. Okay? Now, if I have 2 different things under the root sign, like these are the same, but now I have root a times root b, so this is just going to be the root of a times b, okay? So that's pretty straightforward. The last one is just like the times, except this is division, this is a quotient. If I have root a over root b, then we can put the root over both of those, put the fraction underneath the root sign, okay? So let's do a few examples. How about for this first rule? Root a times root a, that's very similar to root 2 times root 2. So that's going to be root 2 squared, or just 2. And by the way, you can pause the video right now and try these next 2 examples. I'm going to keep working. So this one, root 2 times root 18, we're going to multiply the 2 times the 18 and pull out a root 36. Now you have to pay attention and look for your perfect squares. We know what the square root of 36 is. If you know it, you've got to pull that out. So this would not be a full points answer. You need to go all the way to 6. Let's take a look at the next one. Root a over root b is the same as the root over the fraction inside. So this is going to be root 50 over 2. Now we can evaluate this fraction. What's 50 over 2? 25. So that's root 25. And 25, guess what? Another perfect square, so that comes out as a 5. Okay, let's do a few examples. I moved the rules right over here so we have them for our reference. We're going to do 3 examples here using those rules. Okay, so let's take a look at this first one. Root 2 to the 3rd power. Let's write that out. I know what that is. It's root 2 times root 2 times root 2. So let's write that out. Not a. Root 2 times root 2 times root 2. Now, we can write that in another way. This is root 2 squared. Right? Now, we know that root 2 squared is just 2. So this becomes 2 root 2. And this introduces us to our first kind of mixed root expression. We can commonly have numbers outside the root sign and numbers inside the root sign. Okay, so you're going to need to get used to that. We're going to do this a lot. Okay, let's take a look at this next one. This is going to be 4 squared, because the power gets distributed to the top and the bottom, over root 2 squared. We know what 4 squared is. That's just 16. Now root 2 squared is just 2. Finally, reduce our fraction. That one ends up being 8. So that's a nice clean solution or answer, no root signs in it. Sometimes you get that, sometimes you don't. Okay, now this one, the exponent is going to get distributed on the root 2 and on the 3. So that's going to be 3 squared times root 2 squared. 3 squared, we do that all day. That's 9. Root 2 squared is just 2, so that's 9 times 2. So that one is 18. Okay, let's do a few more. And remember, you can always pause the video before I explain a problem and see how well you do on your own. All right, let's take a look at this one. This is a little different. We have two mixed root expressions with numbers on the outside and numbers on the inside. So the way you do that is you multiply the numbers by the numbers and the root things by the root things. So this is going to be 3 times 2 times root 3 times root 3. Okay, so that's pretty straightforward. 3 times 2 is 6. Root 3 times root 3 is root 3 squared, which is just 3. So this is going to be 18. Okay, now let's try that one. Pause the video, see how you do it. Okay, minus 2 times 3 is negative 6. Root 5 times root 5 is just 5. So this one is minus 30. So you probably noticed as I explain these, I'm starting to show fewer and fewer steps. It occurs to me right now, while we're recording this video, that we could make a rule here. We could say a times root b times c times root b. Again, rules have just general letters. This is going to be a, c, b, right? Because root b and root b are just going to become b, and a times c is going to be there, so it's going to be acb. We could develop another rule. Let's try a times root b times c times root d. Now this one's a little bit more complex because we're not going to be able to resolve the two root b's to just b, so we're going to have ac times root bd. So far, we don't have these rules expressed formally, but they totally work. So if you wanted to write them down and use them as you do these problems, particularly the ones that look like these two, these will be helpful for you. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.